Hey everyone, Geophysicist Stefan Burns here with an update for you on earthquake activity in California because we've had a surge of earthquake swarming in and around the Golden State just over the past few days, and we've also had some high magnitude events over the past week, specifically this magnitude 6 earthquake there that struck off the coast of Oregon just nearby. That is a big earthquake, the strongest that we've seen in this specific section in recent time. But notably, there has been an earthquake swarm here just near Indio, California, in Southern California, that's had more than 350 earthquakes now. So the first one to pop off was a 4.9. That was at a depth of 3.1 kilometers, and that was on the 19th California time. But if you look here at Universal time, is at 1:56 a.m. in the morning on the 20th. And then we had a whole bunch of magnitude 3 plus earthquakes, magnitude 2s, 1s, and lesser earthquakes. Of course, the way earthquake magnitude scales is if you go up one order of magnitude, that's 32 times more energy. So that 4.9 contained almost all the energy in that swarm up until today when we've had a magnitude 4.3 aftershock. And that is a sign that this may be more than just a magnitude 4.9 in aftershock sequence. It actually may be a foreshock earthquake swarm to something larger, because the typical rule of thumb is that whatever the main shock magnitude is, the strongest aftershock will be one order of magnitude less, meaning that that main earthquake at 4.9 would trigger perhaps, it's not always the case, but perhaps an aftershock of a magnitude 3.9. We saw that we had a 3.8, 3.7, 3.5. That's right up there. Now we've had this 4.3. So there is a big difference between the strength and energy of a 4.3, 4.9, but it does buck that trend. And then you add in the fact that we've had 350 plus events overall. This is looking like a foreshock swarm to something larger. And it's not the only earthquake swarm that we've had. We've also had this magnitude 4.1 earthquake here in Holtville. This was back on the 15th of January, Universal time, and that struck at a depth of 16.2 kilometers. But you'll notice also 75 earthquakes in this surrounding area. If we really punch in right here, we see 72 earthquakes as a result of that. So that's also a notable earthquake swarm pretty close by. You see that this swarm there with Indio is right near the San Andreas. Well, also that one in Holtville. We have another earthquake swarm that's been popping off here in and around Johannesburg. And we see that there are 35 earthquakes here, magnitude 3.6 being the strongest. That was at a depth of 4.5 kilometers. And we've also had some activity just outside of California in Nevada. And so here we see a magnitude 3.8, 3.7, 3.5, and 9 other earthquakes as part of this mini swarm too. So that's just outside of California, and it's part of the overall larger fault system because California is quite complex with its faulting. You have the San Andreas, but then you also have the Garlock fault, and then you have all these faults going through the Sierra Nevada, and then you have the extensional basins. And so effectively, the stress dynamics between the Pacific plate and the North American plate spread out across this entire region. It's not just contained with the transverse strike slip fault where they slide past each other of the San Andreas. But there's more than just that. We also had this magnitude 4.2 here off the coast at the Triple Junction. You'll remember back in 2024, December 5th, there was a magnitude 7 there. That's the strongest earthquake California's had in quite some time. We saw these unusual pre-earthquake signals out of Tomsk, Russia, just a few days before that earthquake. And well, I mention that because we've just recently seen some pre-earthquake signals out of the same observation station. In fact, these are unprecedented in nature due to their characteristics and their duration. So things are feeling very similar to back in December of 2024 when that magnitude 7 popped off, but this time we're looking at a much more significant pre-earthquake signal here. We have 3 days across the board, almost 3 days of these signals. We have 0 to 40 hertz. This is a vertical electric field spectrogram. We're looking at effectively the vibration of electric current in the atmosphere going from the ground surface up to the ionosphere. And if you didn't know, we have a lot of electric properties to the Earth. The ionosphere above us, the uppermost part of the atmosphere, is charged, has a voltage of about 250,000 volts. We call this an equipotential. It's about equal across the globe, though it's more highly charged in the polar regions on both sides. And the ground surface is about 0 volts with its potential. So you get this current that flows between them, and there can be little oscillations and vibrations that exist there. These are the Schumann resonances. We see these bands here, Earth's naturally resonant energy fields created by lightning strikes, also ionospheric processes, space weather, our brains also. It's very interesting. They are always resonating. When we see signals and deviations from the normal background vertical electric field and the Schumann resonances, that often is a sign that we have a big earthquake coming. These are pre-earthquake signals. We have a rich body of observational evidence showing that pre-earthquake signals appear before high magnitude earthquakes. A clear example of that is Loma Prieta in 1989. They happened to put a magnetic field observation station just 7 miles away from the epicenter before the earthquake struck. It was just a really good coincidence. And well, when that earthquake struck, we noticed all these unusual electromagnetic signals. There are pre-earthquake signals, during, then also post-earthquake signals. The overall magnetic field was elevated for not just days, but weeks and months afterwards. So we had to take these sort of signals seriously, and being nearly 3 days in duration, I've never seen them be that long. I've never seen them have this frequency architecture before, where we have two main zones, the higher frequency, the lower frequency ones, spreading out as well. There's this bifurcation that occurs right there. This is highly anomalous. One of the key factors we look at to really confirm that these could be pre-earthquake signals is the Q factor. This is a measure of resonance amplification. So if you have a system that's resonating, you have energy going in, you have energy that's leaving. You can consider the energy leaving like friction. It's the damping factor. Well, if you have more and more energy going in, but the amount of energy leaving is the same, or it's actually diminishing, that resonance builds like this. That's resonance amplification. And we often see dramatic spikes in resonance amplification just before high magnitude earthquakes, magnitude 6, 7, 8. So here we see that the Q factor for 20 hertz mode 3 of the Schumann resonance went up to 310. Normal value is about less than 20. And then we see for mode 2 here at 14, 15 hertz, it went up to 130. Mode 4 up to 54 at times. So we had big spikes in the Q factor across modes 2, 3, and 4 of the Schumann resonance. That's 14 hertz, 20 hertz, and 26 hertz. That is highly anomalous. So we've had these pre-earthquake signals, and we've had a lot of notable earthquake activity in and around California. And I want to show you another earthquake that's worth paying attention to is a magnitude 4.4 that struck Willits just recently. So here we have a whole bunch of historic earthquakes I've loaded into a Google Maps project. We see the magnitude 4.4 there. That was on the 13th of January of this year, 2026. And I have a whole bunch of magnitude 7s and 6s and 5s. This is all from a video that I made on California's earthquake history. I'll link that in the video description if you want to better understand the overall dynamics of stress with the San Andreas Fault and the earthquakes that we get. Two things to notice before we go back to that earthquake for Willits is we see the San Andreas here. See that bend? That's why we get big earthquakes on the San Andreas. That bend builds up stress, and then every now and then it will have this severe rupture. And we also have a bend up here. So we have two bends in the San Andreas. And what's interesting is if you look at earthquake activity, there's really no earthquakes in this block there or that block there, but we do get this line of historic earthquakes going across right at that bend. And so they're very uncommon. Even like magnitude 4s are very uncommon here. We had this 6.7 in 1898, then we had this 5.5 in 1888. So it's like a little bit of a foreshock right here. Then this 4.7, 4.9, 4.8, 4.8, 4.8. So you see that they go across with time for the most part. This 4.4 is now the latest in that sequence, going across about 130 plus years now. There's very few earthquakes that ever strike there. So the fact that we did have an earthquake strike there just recently is a sign that these faults are more active than they have been in the past, and that we should really pay attention. So it's looking like we have something big coming for California based off of all the earthquakes swarming that is currently active. Going back to our USGS map, let us turn off our small earthquakes here. So right now it's set for all magnitudes. Let's set for magnitude 2.5 and greater. You see that changes the map quite a bit. There's always a lot of low magnitude earthquakes. This would be like magnitude 0 plus earthquakes, magnitude 1, magnitude 2.1, 2.2, right? They are worth paying attention to. They come in a swarm, but individually they're not really worth paying that much attention to. Because again of how earthquake energy scales, 1 order of magnitude up, 32 times more energy, 2 orders of magnitude up, that's 100 times more energy. So when you start to have these magnitude 4s versus magnitude 2 or less, it makes a difference. But we do see that there is a clustering of this activity down here in and around Southern California. And of course that magnitude 6 there, the 4.1, right, 4.2 right there with Petrolia. And if you go to our 30-day view, we will also see these quakes up here in Susanville. So that's a 4.9 and also 4.7, as you can see. So there's been some significant activity in and around California for the past month, but now it seems really in just the past week it is accelerating, most notably with that magnitude 6 just north of California. And then again, we had this earthquake swarm here in Nevada. So it's just showing that the overall larger regional stress dynamics of the western coast of the United States is accelerating, because you can't look at any one location too closely. You'll lose sight of the forest for just looking at the tree. But when you put all this together, the earthquake swarming in Nevada, showing that there's a stress unfolding that's occurring here in these faults more to the east. You have these magnitude 4 quakes there in Southern California, magnitude 6 there. You have the 4.2 on the Triple Junction. You have the Susanville quakes, which are pretty bizarre. You have the 4.4 Willits right on that bend. All that put together is indicating that we could have something bigger coming to California soon. We're well overdue. Let's just say that. We're well overdue for a large earthquake in California. Unfortunately, that is the case. There are other areas of the globe that are much more seismically active. Japan being very notable, being a very small landmass in terms of global surface area, but having a huge amount of earthquakes in terms of the percentage. The overall Western Pacific Ring of Fire is much more active than the Eastern Pacific Ring of Fire in general, though that does change as you get down to Mexico, South America. And that is part of the puzzle, because if all this is part of effectively one plate, which is the Pacific plate, right, and you're having all this movement here, and you're having a good amount of movement here and also with Mexico and, Alaska, Yukon, and there's so little activity here, eventually that's got to move. We've seen big slip and movement before from the San Andreas and associated faults across time. The San Andreas can do some really big movements and effectively catch up. Some of the stress in California is released as a slow slip, so there is that, but it's about a third or less of the overall strain that's being put on the boundary between the Pacific and the North American plates. So eventually you have the big earthquake and you get most of that strain release and you get the big fault movement. And this can be 2 feet, 3 feet, 8 feet. It can be really significant. So if we are to get a big earthquake in California, there's a variety of faults that are overdue. The Hayward Fault is one in particular. Last big earthquake was back in the 1860s. It was a magnitude 6.8, if I remember correctly. We have the Green Valley Fault, the Calaveras Fault. Napa's had a lot of earthquake activity just in the recent past 21st century, past 26 years, with the magnitude 4.9, then also the magnitude 6 in 2014. That's the biggest earthquake that the Bay Area has had in the 21st century. But the San Andreas is really the big fault that probably is most likely to give us a big rupture, magnitude 7 or greater. We hope that doesn't happen, but it's good to be aware and prepared. And when I see all this distributed earthquake activity in and around California at this moment in time, I think it is definitely worth paying attention to, because we see that there is a huge population density in California. It's the most populous state, so it's good to be aware and prepared. And we see that the seismic hazard is quite high, especially for places like Southern California here and the Bay Area. We have very high seismic hazard for the state, and that does go all the way up to the Triple Junction and going through into Oregon beyond because of the Cascadia fault, and that can have big magnitude 9s. So that subduction zone hasn't had a big earthquake like that since 1700. So all these dynamics are possible. We did have a magnitude 3.8 here in Illinois, just outside of the New Madrid fault system. And an interesting thing to be aware of is that we had all these earthquakes striking the New Madrid fault system back in December of 1811, going through the spring of 1812. And then it was the winter of 1812, it was December, that we had 2 big earthquakes strike Southern California, magnitude 7 plus. So there is this dynamic, it seems, at least based off of the last recent big seismic bursts between the two, that when you have earthquakes pop off here, you often have earthquakes pop off there. And in 1812, we also had a magnitude 7.7 earthquake in Venezuela known as the Caracas earthquake. So that time period, end of 1811 and all the way through 1812, was very busy. We had all these earthquakes, and then in March you had the 7.7 Caracas, and then in December, within 2 weeks of each other, you had a 2 magnitude 7 plus earthquakes. So it was very dynamic. And right now we're seeing a lot of activity in California. So I wanted you to be aware of that. I will keep you up to date with everything that's happening. Again, I've been your host, Stefan Burns. Please smash that thumbs up button to help the channel grow. If you'd like to learn more about what's happening with the earth, then please subscribe. I cover what's happening here with earthquakes, volcanoes, severe weather, geomagnetic storms. We've just had a huge geomagnetic storm from one of the strongest solar storm impacts in decades. In fact, that geomagnetic storming is still occurring, and that increase in overall energetic flux across the entire earth does seem to make these sort of events more common, because it's just adding more energy into the system, more volatility. And if you have magnetic flux, you're generating electric currents in the subsurface, and when those pass over fault zones, that can cause ruptures. So that could be an explanation as to why we have all these earthquake swarms now popping off in and around California. It's hard to say 100%, but that certainly is a factor to be aware of. So we cover the space weather, we cover the planetary resonances, solar activity, and so much more. Hope to see you around. Thank you all so much. Wishing each and every single one of you well. Please take care of yourselves, and I'll see you all very soon.